Welcome back to the Deep Dive, the show where we take a whole stack of complex source material and really just boil it down to what you need to know.
Today, we are heading into some pretty technical territory. We're navigating the world of API management platforms. This is, the hidden plumbing of the internet that really determines how big companies manage their digital front door.
It is. And for our listener, the learner, who we're imagining is stepping into this for the very first time, it's just a wall of names. You hear Apigee, API gateway, cloud endpoints, and you have no reference point. It's like trying to understand a factory floor just by looking at the machines.
And that is exactly our mission today.
Right.
To give you that reference plane. And to be super clear, we are focusing only on the API platform part. We're not talking about the databases or the code in the background.
Right.
We're talking purely about the management layer. The tools that sit in front of everything to, control who gets in, how often they can ask for things, and crucially, how you charge them for it.
We're going to help you understand the big trade-offs. When do you need something simple and cheap versus when do you absolutely have to have the big, expensive, all-singing, all-dancing enterprise solution?
To do that, we have to start at square one. I mean, what even is an API?
Application programming interface,
Yeah.
It's a mouthful.
It is. But really, at its core, it's just a contract. It's a set way for two different pieces of software to talk to each other and exchange information.
And this is where we have to bring in the classic analogy because it just works so perfectly. The API is the waiter in a restaurant.
It's the best metaphor, honestly. So imagine you're the customer, the client, sitting at the table.
Okay.
And the kitchen, that's the backend system. That's the complex database where all the valuable stuff, the data, is kept.
And I am not allowed in the kitchen. I don't know how it works. I don't want to know.
Exactly. You would never just get up and run into the kitchen to shout your order at the chef. That would be total chaos. It's insecure. It's inefficient. Instead, you talk to the waiter. That's the API. You give your request to the waiter takes it to the kitchen prepares the order, and the waiter brings the response, your food, your data, back to you.
The beauty of it is that I only need to know what's on the menu. I don't need to know the recipe or the brand of the oven.
That's the abstraction. That's the API. But, and this is the pivot for our whole discussion today, that works fine with one waiter and one customer. What happens when your restaurant is serving millions of customers a day all at once?
And that one waiter needs a whole management team behind them.
Precisely. And that management team is the API platform. It's the host at the front door seating you. It's the bouncer checking your ID. It's the security guard watching for trouble. And it's definitely the accountant tracking every single order so they can create a bill.
And all our sources really point to three main reasons organizations pay for this management layer, which is how we'll structure this. First, security. Who gets in? Second, traffic control. How fast and how often can they ask for things? And third, monetization. How do we make money from this service?
Those three needs drive everything. They determine which of these platforms you're going to need.
Okay, let's start with the most urgent problem. Protecting the kitchen from getting completely overwhelmed.
The first thing you worry about when you expose a service is just overload. Your backend system, your kitchen, it has a finite capacity.
Right. Can only cook so many dishes at once.
Exactly. And if you get a sudden flood of orders, it doesn't just slow down, it can crash. The whole system can just fall over, and then nobody gets their food, not even the legitimate paying customers.
We hear about this as a denial of service attack.
Yeah.
Sometimes it's not even malicious, right? It could just be, I don't know, a bug in an app or a sudden viral news story.
Correct. Malicious or accidental, the result is the same. The system is down, you're losing money, and your reputation is taking a hit. This is why you need really granular traffic control policies. And we need to break down two that sound similar but do very different jobs. Quota and spike arrest.
Let's start with quota. That feels like the more intuitive one.
It is. A quota policy is basically a budget. It says a specific user or partner is allowed, say, 10,000 API calls per day, or 1 million per month. It's about managing resource consumption over a long period.
That makes total sense. I need to plan my capacity. I need to know what my cloud bill is going to look like. But, and this is the key point I saw in the sources, a quota manages the total amount, but it says nothing about the pace.
And it's the pace that kills systems. That is the specific job of a spike arrest policy. Think of it as an immediate circuit breaker. It's the bouncer who steps in to stop a short, violent burst of traffic that would overwhelm the system right now, even if the user is way under their total daily budget.
The example from the source material makes this so clear. Let's walk through it. Imagine you have an older legacy database,
Yeah.
a very common enterprise situation.
Very common.
And this database has a hard physical limit. It will crash if it gets more than, say, 100 requests per second.
Right. It's just not built for that kind of modern, spiky traffic.
Hmm.
Now, let's say you have a big partner, a valuable customer, and you've given them a really generous quota, maybe 100,000 requests per day.
They're a good customer. We want them to be happy.
We do. And if they spread those 100,000 requests out evenly over 24 hours, that's barely more than one request a second. The system is perfectly happy, no problem at all.
But what happens if they have a software bug, or they launch a huge sale, and for 5 seconds their app just goes crazy and sends 500 requests every single second?
Well, let's do the math. 5 seconds at 500 requests per second is only 2,500 total requests.
Which is tiny compared to their 100,000 daily quota. They haven't even made a dent in their budget.
Exactly. Their quota is fine. But that 500 requests per second is 5 times the safe limit of the backend. That flood of traffic will crash the database instantly. Spike arrest is what prevents that. It's watching the clock second by second, and it says, whoa, in this 1 second window, we've already seen 100 requests. We are going to gracefully reject every other request for the rest of the second to protect the backend.
The analogy then is perfect. Quota is your monthly data plan on your cell phone. It's your total budget. Spike arrest is the circuit breaker in your house that stops a sudden power surge from frying your TV right now, regardless of how much electricity you're allowed to use this month.
And that ability to protect older, fragile legacy systems is a non-negotiable enterprise feature. It's one of the first big reasons you'd choose a sophisticated platform like Apigee over a simpler gateway. It's not just blocking traffic, it's intelligently managing the flow to guarantee stability.
And it has to do it gracefully, right?
Yeah.
It sends back a proper error message, like a 429 too many requests, so the app on the other end knows what happened and can back off.
It's intelligent cooperation, not just a brick wall. It manages the client's expectations while ensuring the service survives.
Okay, so that's managing the volume. Let's move on to managing who is sending the traffic.
Yeah.
Security, the front door.
The absolute baseline here is API key authentication. It's like your library card or your gym membership ID. You present your unique key with your request, the platform checks if it's valid, and if it is, you're allowed into the next stage.
That's table stakes. Pretty much every tool does that. But the threats today are so much more sophisticated than just someone stealing a key. The sources talk a lot about bot scraping.
This is a huge problem. Say you have valuable data, real estate prices, stock quotes, flight information. Malicious actors want to copy all of that data constantly. The old way to stop them was to rate limit a specific IP address. If one address sends too many requests, you block it.
But the bad guys are smart now. They don't use one computer.
Not at all. They use massive cloud infrastructure. They can spin up thousands of virtual machines, each with a completely different IP address. Each individual machine might only make one request every few minutes.
So to the platform, it just looks like thousands of different slow individual users. Each one is flying completely under the radar of a simple IP-based rate limit.
But taken together, it's a massive, coordinated scraping operation that's stealing your core business intelligence. The old defenses are useless.
And this is where things get really, really interesting with more advanced platforms. The solution here is something called Apigee Advanced API Security, which is all about machine learning.
This is a total shift in thinking. Instead of static rules like block this IP, the platform starts asking behavioral questions. It asks, does this overall pattern of traffic look like how humans behave, or does it look like a machine?
So what is the ML model actually looking at to figure that out? It's not just the IP address anymore.
Right. It's analyzing dozens of signals at once. It looks at the timing, the cadence. Are requests coming in at perfectly spaced intervals, 247? Humans aren't that consistent. It looks at geography. Are all these thousands of supposedly random users all making requests that originate from a single AWS data center in Virginia? That's suspicious.
That's a fantastic tell. Another one could be that the bots only ever hit the data endpoint. A real human developer would also be hitting the documentation pages, the login page, their account page. The bots don't do that.
Precisely. It's that holistic picture, the combination of perfect machine-like timing, weird geographic clustering in known cloud provider IP ranges, and a complete lack of any other human browsing behavior. The system puts all that together and says, that's a bot, and it blocks the entire operation automatically.
For a business whose entire value is that data, that kind of protection is not a nice to have. It's a fundamental requirement you just don't get with the simpler tools.
It's a core enterprise security feature.
Okay, let's switch gears from defense to offense. Not just protecting our data, but making money from it. Monetization.
Right, because for so many companies now, the API is the product. You're literally selling access to your data and services.
When that happens, the platform has to be more than a guard. It has to be an accountant. It needs to handle complex billing and subscriptions.
And this is where we see the concept of API product tiers, which is a key feature in a platform like Apigee. It's about creating different packages for different types of customers.
So let's walk through what a typical set of tiers would look like for, say, a financial data company.
Yeah, okay. You'd almost always start with a free tier. The limits here are very low, maybe 100 calls a day. The point isn't to provide a real service, it's a marketing tool. It lets a new developer sign up, test the API, and build a prototype without having to get a credit card approved. It lowers the barrier to entry.
Get them hooked. Then once their app is working and they need to go live, they upgrade.
They upgrade to the silver tier. This might give them, say, 10,000 calls a day for a flat monthly subscription fee. This is your standard, predictable business. The platform has to track their usage and, critically, enforce that limit automatically.
And if they start hitting that 10,000 call limit every day, they need to move up again.
Right, to the gold tier. This is for your huge enterprise partners. It might be billed as unlimited, but really it's a sophisticated pay-as-you-go model. You pay for what you use.
And this is where the platform has to be incredibly robust. It's not just counting calls anymore. It has to integrate directly with the company's billing and finance systems.
That's the key differentiator, built-in billing integration. The platform needs to track every call, know which tier the customer is on, calculate overage charges, maybe even handle different currencies or taxes, and then feed all of that clean, auditable data into an ERP system to generate an accurate invoice.
You can't just hack that together with a few scripts. That's a core financial process.
It is. And the need for that kind of robust, auditable, enterprise-grade monetization is probably the biggest single driver for choosing a full-featured platform. It's about turning your API into a real, scalable business.
Okay, we've laid out the why: security, traffic stability, and monetization. Now let's get into the what's and directly compare the tools: API gateway, cloud endpoints, and Apigee. Simple, specific, or sophisticated?
It's a great way to frame it. And the choice really comes down to which of those whys are most important to you.
Let's start at the beginning. Simple and cost-effective. API gateway. What's the perfect use case for this?
The perfect use case is when you have a bunch of back-end microservices. Maybe you have 5 or 10 small services running on something like Cloud Run or Cloud Functions.
And you don't want your users to have to know the URLs for all 10 of those little services.
You want one single stable front door, a single URL that acts as the entry point. API Gateway does that perfectly. It takes the incoming request and routes it to the correct backend service.
And in terms of features, what do you get? What are you settling for?
You're getting the basics. You get that routing, and you get simple API key authentication. It checks the ID badge and directs traffic. That's its job. It's designed to be lightweight, low cost, and easy to manage.
So the main driver here is cost and simplicity.
Yeah.
You're not paying for a bunch of enterprise features you don't need.
Exactly. Why pay for a whole monetization engine if all you need to do is route traffic to 3 serverless functions?
Let me play devil's advocate for a second. If I only need a very simple rate limit, why can't I just write that logic directly into my Cloud Function code and skip the gateway altogether?
You could. People do. But the problem is sprawl. Now you have that security logic copied in 5, 10, 20 different places. If you need to make a change, you have to update and redeploy all of them. It becomes a management nightmare.
So the gateway centralizes that policy. Write it once, apply to everything.
It abstracts the policy out of your application code. It's the efficient turnstile at the entrance to a bunch of small venues. It does its simple job really well. But the moment you say, I need that spike arrest feature we talked about, or I need a self-service portal for my partners, you've outgrown it.
Okay. So moving up the ladder in complexity, we get to cloud endpoints. This one feels a bit more niche.
It is more specialized. It's really focused on high-performance scenarios, especially when you're heavily invested in containers, like with Google Kubernetes Engine or GKE.
And the killer feature, the thing that makes it unique, is something called gRPC transcoding. That is a lot of jargon. Let's break that down.
Let's do it. So first, gRPC. It's a modern way for services to talk to each other, developed at Google. Unlike the normal web standard, HTTP JSON, which is text-based.
Something a human can read.
Right. gRPC uses something called protocol buffers to send data in a very compact, efficient binary format. It's much, much faster for communication between internal services.
So it's like a high-speed internal shorthand that your microservices use to talk to each other inside your data center.
Perfect analogy. But here's the problem. The outside world, a mobile app, a partner's web service, they don't speak that shorthand. They speak normal, plain text, HTTP JSON.
So you have a language barrier.
You do. And transcoding is just a fancy word for translation. Cloud Endpoints acts as that real-time translator. It intercepts the normal HTTP request from the outside world, converts it into the high-speed gRPC format your backend needs,
And then translates the gRPC response back into normal HTTP before sending it back out.
and it has to do this translation with almost zero delay, or you lose all the performance benefits of using gRPC in the first place. This is why its deployment model is so important. It runs as a sidecar container.
Okay, a sidecar. That's a Kubernetes concept.
It is. It just means the translator container runs right next to your main application container in the same little logical unit. They're practically touching, so the latency of that translation is incredibly low.
So why choose Cloud Endpoints? You choose it when you don't have the budget for full Apigee, but you have a very specific, high-performance need for that gRPC translation, especially in a containerized world. It's the specialized interpreter.
It's a scalpel, not a Swiss Army knife.
Which brings us to the Swiss Army knife, or maybe the whole toolbox, the Apigee family.
This is the heavyweight champion. Apigee is what you choose when the business stakes are incredibly high, and you need a platform that integrates every single one of the advanced features we've discussed.
So we're talking about the deep analytics, the dual quota and spike arrest policies, the complex monetization tiers, the machine learning bot detection. It's all in one box.
Right. The rule of thumb is if you have a complex enterprise-grade API requirement, the answer is probably Apigee. You look at the big banks, the big telcos, the big insurance companies. They run on platforms like this. For them, the cost of a security breach or a billing error is so astronomical that the high price of the platform is easily justified.
But it's not just the price, it's the operational overhead, right?
Yeah.
You need a specialized team to run something this complex. Why wouldn't a company just try to build some of these features themselves?
They can try, but the calculation they make is total cost of ownership. The cost of hiring a team of engineers to build, test, secure, and maintain a custom monetization engine, for example, and then get it audited for financial compliance. That cost quickly becomes way higher than just buying the pre-built, battle-tested feature from Apigee.
So you're buying the features, but you're also buying the assurance that it works at a global scale.
You're buying the assurance, the compliance, and the ability to focus on your actual business instead of on building platform infrastructure. The choice for Apigee is almost always a business decision, not a purely technical one.
Okay, so let's dig into a couple of those make-or-break enterprise features that really set Apigee apart. The first one is about managing relationships at scale, the developer portal.
This is so critical. If your business model is to have hundreds or thousands of external partners build applications using your API, you cannot manage that with email and spreadsheets. You just can't scale.
You need an automated self-service storefront for your APIs.
That's exactly what the Integrated Developer Portal is. It's the front door for your entire partner ecosystem, and it automates the whole onboarding process.
Let's walk through that process from the developer's point of view. What do they do?
Okay, so a new developer comes to your portal. First, they do app registration. They sign up, create an account, agree to the terms, all without talking to a human.
Then they need their credentials, their API key.
Second step, API key acquisition. The portal provisions and gives them their key instantly. The process that used to take days of back and forth emails now takes seconds.
Okay, they have a key. Now they need to know how to actually use the API. They need the manual.
Right. And a static PDF manual is terrible. So the third function is interactive documentation. The portal hosts the API specification in a live format where developers can read about the endpoints, see code examples, and, this is the best part, make actual test calls to the API right there in their browser.
So it radically shortens the time it takes for them to get their first piece of code working.
Massively. And fourth, once they're up and running, they need to see their own usage. If they're on a tier with a 10,000 call limit, they need to know if they're getting close. The portal gives them their own analytics dashboard.
So they can see their own consumption, manage their own usage, and even upgrade themselves to a higher tier if they need to, all without ever filing a support ticket.
It completely changes the dynamic. Your internal team stops being administrators and starts being product managers for the API ecosystem. It's what allows the program to scale.
Okay, from developer convenience to something much more high stakes, regulatory compliance. This brings us to Apigee Hybrid.
This is a solution born out of a fundamental conflict. The conflict between the convenience of the cloud and the hard reality of global data laws.
You're talking about data residency laws.
Oh.
Things like GDPR in Europe, which say that certain kinds of sensitive user data cannot physically leave a specific country or region.
Exactly. Or rules for financial data or health data. The problem is companies want to use cloud tools for management because it's efficient, but they are legally forbidden from letting their sensitive customer data flow through a public cloud provider's network.
So how does Apigee Hybrid solve that paradox?
It solves it by splitting the platform into two parts: a management plane and a runtime plane.
Oh, explain that split.
The management plane is where you do all your configuration. You define your policies, you design the developer portal, you look at your analytics. This part can run in the cloud because it doesn't actually touch the sensitive data. It just holds the rules.
So my admin team gets a nice centralized cloud dashboard to manage everything.
Correct. But the actual API traffic, the requests and responses that contain the sensitive customer data, that happens on the runtime plane. And the runtime plane, the actual gateway, gets installed on premises, inside the company's own private regulated data center.
I see. So let's trace a request. A customer in, say, Germany makes a request with their private financial data.
That request hits the Apigee Hybrid runtime gateway that is physically installed in your company's German data center.
Yep.
The policy is enforced right there, locally. The request goes to the local backend database. The response comes back.
And the crucial point is that the sensitive data never, ever leaves that German data center. It never crosses the public internet to a cloud provider.
It stays completely within the legally required geographic boundary. This architecture is a brilliant solution for global regulated industries. It gives them the best of both worlds: centralized cloud management and strictly localized compliant data processing.
It shows that the choice of platform can be driven not by a feature you want, but by a multi-million-dollar fine you absolutely have to avoid.
That's enterprise decision-making in a nutshell.
Okay, we have covered a huge amount of ground. Let's try to synthesize this all into a final takeaway for the learner.
Let's do it. We can really boil it down to a simple decision tree.
Go for API Gateway when your primary drivers are simplicity and cost. You have a simple serverless backends, and you just need that basic routing and a simple API key check. It's the turnstile.
Choose cloud endpoints when you have a specific high-performance requirement, almost always gRPC transcoding. You're living in a containerized world, and you need that specialized, low-latency translator.
And you step up to Apigee when the API is a core part of your business strategy. You need the full suite: enterprise security, complex monetization, the self-service developer portal, and, maybe most importantly, the hybrid deployment model to meet strict regulatory demands. It's the full command and control center.
And that's really the bottom line. The decision isn't just about technical features. It's about aligning the platform's capabilities with your business risk, your revenue model, and your compliance requirements.
If your revenue depends on it, if your partners pay for it, if your regulators demand it, you need the enterprise-grade solution.
You're buying a management layer that is as valuable and as complex as the assets you're putting behind it.
So for our final provocative thought, we talked about Apigee's advanced API security, how it uses machine learning to spot bots by looking for non-human patterns.
Right, the perfect timing, the weird geography. It's looking for behavior that gives the game away.
But what happens in a few years when the bots are also driven by sophisticated AI? When the consuming application is an AI that has been specifically trained to mimic human behavior perfectly. It could learn to introduce random delays, to browse documentation pages occasionally, to vary its request pattern.
To essentially generate traffic that is, from a behavioral standpoint, completely indistinguishable from a human.
Exactly. So if you can no longer tell the difference between a bot and a human, does our entire model of traffic control, which is based on that distinction, become obsolete? If you can't identify the bad traffic, how do you manage it?
That is a fascinating question. Maybe the future of API management isn't about trying to categorize callers as human or machine at all. Perhaps it has to evolve into a system that prioritizes traffic based on business value. It doesn't care who you are, it cares about the value of your transaction or the level of your partnership agreement. A request from a gold tier partner gets priority, regardless of whether it's a human or an AI making the call.
The job shifts from being a bouncer to being a concierge, dynamically allocating resources based on relationships, not identities. Something to mull over.
Definitely. The cat and mouse game continues.
And on that note, thank you for guiding us through this. It was a fantastic deep dive. We'll see you next time.